For this question, you have to find all the roots, the indicated roots. That's the cube root of z, where z is negative 3 minus 3i. And to express z in its exponential form and find the natural logarithm of z. So, pause the video, write it down, and then work it out. After you work it out, then you can watch the rest of the video. Okay, so you're finished? Good. So, let's see how this goes. We have z is equal to negative 3 minus 3i. Remember, to find the root of z, we're going to write it in polar form. Alright? Now, remember also, there are 3 cube roots of z, and they'll be separated by 360 degrees over 3, which is what, 120 degrees. Right? If you were working in radians, it would be 2 pi, which is the same as 360 divided by 3, or 2/3 pi radians. But let's deal with degrees for now. We can write the exponential form in degree or radian, but when we find the natural log, we'll have to convert any degrees we have to radians. When we get there, we'll deal with that. Now, z is equal to negative 3 minus 3i. Now, if you have your x-axis and your y-axis, and you go to negative 3 minus 3i. So remember, the negative 3 would be 3 to the left from the origin along the x-axis. Negative 3i right down here would be 3 down. See, this is negative 3 down, of course, along the y-axis. Right? So this is z. Negative 3 minus 3i. Alright? Now, the magnitude of z, if you consider this triangle here, we have a 90 degree here, this is 3 and this is 3, or you could consider this triangle if you want. You have a 90 degree here, right? This is 3, this is 3. So the magnitude of z would be this line, complex number. It's going to be the square root of negative 3 squared plus negative 3 squared. Alright? Pythagoras theorem. Right? 3 long, 3 long. So this would be what? Square root of 3 3 is 9 plus 3 3 is 9. Square root of 18 is the magnitude. Now remember, the polar form is z is equal to r cos theta plus, well, they use I, so let's use I r sine theta. Remember, that is the polar form. And remember where it comes from. So a little review here. You have the x and y axis, and you have your r here. This would be your triangle. So if you take out this triangle, this is theta, this is r, the magnitude of z would be r, alright? You call it r. Now this is your adjacent to theta. and this is your opposite to theta, right? Now cos theta is the adjacent, right? So the adjacent over hypotenuse r. So, alright, what is the adjacent? Is r cos theta. So that's r. The opposite. Now remember, sin theta is the opposite over the hypotenuse r, so the opposite would be r times sin theta. Alright? So when you say x plus j or x plus I y, you're saying adjacent plus I opposite. You're saying r cos theta, the adjacent, plus I r sin theta, the opposite, right? So remember, that's where it comes from, the polar form of the complex number. Alright, so we have r, which is a square root of z already, magnitude of z, square root of 18, right? R is the square root of 18 in this case. Now we need theta, the angle. Now remember, theta, the angle is measured from 0, which is here, in an anti-clockwise direction. So all of this is theta. Let me just make a mark here. It should be theta, right? Now if you find this angle, call it alpha. Alpha. Oh, it's not that angle I want. This is the angle alpha. Let's call this alpha. Alright? So alpha. Now tan alpha is the opposite. Is this over the adjacent, which is this. So alpha opposite over adjacent. Alright? In this case 3 over 3, which is 1. So alpha is the tan inverse of 1. Well, you don't even need a calculator. You know that if you have a triangle here, opposite and adjacent are the same, this will be 45 degrees. Alright? So the total angle, theta, that is the angle from here all the way around, would be 180 plus 45. So it's 180 plus 45, which is what? 180 plus 20, that's 200, plus another 20, 220, and then 5 more, 225 degrees. Alright? Now they ask you for the cube roots, but the thing here, the polar form is z is equal to square root of 18 cos 225 plus I square root of 18 sin 225. You could also factor out the square root of 18 if you want, but I like writing it long way like this. Now here, remember, when you find the root, you use De Moivre's theorem. Alright? If you have z is equal to r cos theta plus I r sin theta, then z to the n would be r to the n cos n theta plus I r to the n sin n theta. That's De Moivre's theorem, right? But the thing is, when you raise a number to a fraction, the top or the numerator gives you the power, and the bottom or the numerator or the denominator, I mean, gives you the root. So if you say z to the power of 1 over n, which would be r to the 1 over n cos 1 over n theta plus I r to the 1 over n sine 1 over n theta. This would be the same as r to the 1 over n, meaning the nth root of r, cos 1 over n times theta would be theta over n, right? Plus I nth root of r sine theta over n. Okay? But remember, this is the basic formula for the Morse theorem. Alright, so the cube roots. There will be 3 cube roots. Right? So, cube root of z1, our first cube root, is going to be, you have the square root of 18, but which will be raised to the 1/3. Square root of 18 to the 1/3, right? Whatever that is. You can find the cube root, the square root of 18, and you get the number, and then the cube root of that number, or that number to the 1/3 if you want, no problem. Cos 1/3 of 225, right? 1/3 by 225 plus square root of 18 to the 1/3 I. I'll lift out the I. Let me rewrite that. Or the J. I prefer using J. I is used generally, but in engineering you don't, particularly electrical engineering, you don't want to mix up the I with I for intensity of current. But anyway, I use I here. I square root of 18 to the 1/3 sine 1/3 by 225. Okay. Now, I'm going to use our calculator and see what happens here. 18, oh, the square root of 18. Square root of 18 equals that. And then that, where's to the power of thing there? To the power of, open bracket, 1 over 3, close bracket, equal 1.619. So this is 1.619. 1.619 cos. Alright, so I'm just going to use my calculator off the air. You could use your calculator as well to verify things. 225 over 3 is what? 75. So it's cos 75 plus I 1.619 sine 75. Okay, so that will be the first cube root. Right? And if you work it out, it would be 1.619 times cos 75. Ensure your calculator is in degree mode. Right? And if you're not sure, what you can do, if you're not sure it's in degree mode, just find the sine of 30 and you should get half. Right? And then you can change it. If you don't get half, then it's not in degree mode. Let me make sure my calculator is in degree mode, and then sine 30 gives me half. Good. So 1.619 times the cosine of 75, you get 0.419 there, and then 1.619 times sine of 75 1.564. That's what you got? Alright. I'll just let it stay here for now. Now the cube root of z, call it the second cube root of z. Now remember, if you should draw the unit circle and the Argand diagram, you're going to have 75 about here. This would be the first z. Now the three cube roots will be separated by 1/3 of 360, which is 120. So the next one will come 75 plus 120 is what? 5 and 0, 0, 7, 8, 9, 190. So the next angle, the next thing there, the next complex number would be here, and the angle separating it would be 120. So from here all the way around would be 5 7 8 9 195. So this will be 195 degrees, right? So this is cube root of z first. This would be the second. So the second cube root of z, remember, the magnitude of the complex number remains the same. It remains as the radius of this circle. It's the angles that will change now. So the second cube root would be 1.619 cos 75 plus 120 plus I 1.619 sine, let me just get this thing out of the way, sine 75 plus 120, which would be what? 1.619 cos 195 plus I 1.619 sine 195. Alright? Then the cube root of z, I call it cube root of z 3rd. For the third cube root, you'd have to swing around another 120 degrees, right? So you have 195 degrees. So, I mean, you have 75. You swing 120 degrees. Separate. There's another 120 degrees from this, right? So it would be 75 plus the first 120 plus the second 120, which would be what? It's like 240 plus 75, 315. That would be 315. Call it about here. Alright? 315 degrees. So you would have 195 plus another 120 to give you that 315 degrees. So swinging all the way around here will be 315 degrees. Alright, so what you have is a 1.619 cos. Now you could write it as 75 plus 120 by 2 if you want. So the first cube root is the angle plus 120 by 0. The second cube root is the angle plus 120 by 1. The third cube root is the angle plus 120 by 2, if you want to consider it that, right? Plus I 1.619 sine 75 plus 120 for the first is 75, the second is 120, the third is 120. But you could just say, instead of 120 plus 120, you could write 120 by 2. Just like this. Alright? So the third cube root is 1.619 cos 75 plus 240. What did I say it was again? 315? I don't really need the bracket here. Cos 315 plus I 1.619 sine 315. A shorter way that you could write it. Although here the cube root of z r, so it's 1.619 angle 75, 1.619 angle, what was the angle again? 195, and 1.619 angle 315, right? You have to remember that it's really in this format. But this is a more advanced way of writing it. Because the person who looks at this should know that what this means is 1.619 cos 315 plus I 1.619 sine 315, right? So you'd have to have passed this stage before going to this stage. It's a more advanced way, right? You'd have to be a more advanced mathematics student to write it in this way. Alright, so as I said, you could get out the numbers, right? You could get the numbers out, and if you get out the numbers, so some number plus I some other number, if you cube it, you should get back your original z, your original z, which is negative 3 minus 3i. Alright? Okay, now express z in its exponential form. So remember the exponential form of z. Let's write it on the right here because we run out of space. Z, the exponential form would be re to the j theta. In this case, I theta you will have. So z is equal to 1.619 e to the I. This was 1.619 e to the first angle was 225. Alright. So e to the I 225. Alright? That's it in its exponential form. After that, let's say find the natural logarithm of z. Okay, so let's see how this goes. We can work on this and say ln z is equal to ln 1.619 e to the I 225. Now, we're going to have to convert the 225 to, by the way, we should have done it before. Alright, so we convert 225 degrees to radians. Now remember, 360 degrees is one complete revolution, one circle. And the way you calculate the circumference of a circle is 2 pi radian. Alright, it's 2 pi r. 2 pi times the radius. Remember that 1 radian is really 1 radius. When you have the radius of the circle being equal to the arc length of that circle, then you have 1 radian here. So it's 2 pi radian. Divide both sides by 2, 180 degrees. Or we don't have to do that yet. If we say we want 225 degrees to radian, turn this into 1 degree by dividing both sides by 360. So 1 degree is 2 pi over 360 radian. Then we turn the 1 into 225, multiply both sides, so you have 225 degrees is equal to 2 pi over 360 times 225 radians. So there you have that. So here now, this would be 22, 123, 60, 180. So it's 225 over 180 pi radians. Let me just use my calculator, put 225 over 180 and make it simplify down. This will be 5 over 4. So it's 5 pi over 4 radians. So the exponential form using radians would be Z is equal to 1.619 e to the I, what was it? 5 pi over 4. 5 pi over 4 radian. Alright, so we want the natural logarithms. ln Z would be ln 1.619 e to the I 5 pi over 4. Now, laws of logarithm. When you have ln a times b, it's same as ln a plus ln b, right? So, just a quick review of that. Suppose you have ln of 5 times 6 close bracket equal 3.4 something. It is same as ln 30 3.4 something. Now, what is ln 5 plus ln 6? Same 3.4 that. Alright? 3.4 something, just the same. So this is ln 1.619 plus ln e to the I 5 pi over 4. Now remember, laws of indices, when you say ln of a power, let me write back this first. 1.619 plus ln a number to a power is the same as the power time ln to the number. Alright? So it's I, the power is I, 5 pi over 4 ln e. But what is ln e? Natural logarithm of e is 1. So what we get is ln 1.619 plus I 5 pi over 4. What is ln 1.619? ln 1.619 equal 0.482. So it's 0.482 plus I 5 pi over 4. Right? So, oh, by the way, hold on there. Let's see something here. Hold on there. The original thing was what? Oh, square root of 18. I was using the 1 point something. This was square root of 18. And then 1/3 it to get the 1.619. No. Is the square root of 18 I should use? I just realized. Mistake there. The magnitude is the square root of 18. My. Is the square root of 18. So this should be the square root of 18. So all of these things should be the square root of 18, not 1.619. It was the square root of 18 and then we found the cube root. So we divided by divided the square root of 18 by 3, right? It was the square root of 18 to the power 1/3, I mean, right? Square root of 18, and then that was raised to the 1/3, right? So we're using the wrong magnitude. What is square root of 18? Alright, let's write it as square root of 18 for now. Square root of 18, that's square root of 18 plus ln plus that, ln that. So is this ln square root of 18 plus that. So the square root, the ln of square root of 18. The square root of 18 is 4.24. Alright? And then the ln of that is 1.4. Is that? Is that so? The ln z, so z is equal to r. So the original thing was 3 3s 9, 9 plus 9, 18. The magnitude was the square root of 18, right? Just double checking and seeing something here. So here now we have r e to the dot, which is square root of 18 e to the dot. Alright, and then we work that out to get e to the 5 pi over 4. 75 degrees is the same as, no, 225 degrees, I mean, is the same as 5 pi over 4. Alright, the square root of ln square root of 18. Good. So the ln square root of 18 is 1.445 plus I 5 pi over 4. If you want, you could say 1.445 plus I, and if you do 5 times pi equal over 4 equal, it would be 3.9. Alright, call it 927. 3.927. Alright, so that's the natural logarithm of z.